In Part 1 of Capitalizing on Carbon, we saw how planet Earth naturally captures and recycles carbon. Now, human industry has grown to the point where we're releasing more carbon than Earth normally handles. But we could capture our carbon and put it to work, recovering oil deep under Earth's surface. Around the world, we use hydrocarbon fuels to generate power. We have 3 different ways to capture the carbon component, depending on how we're generating that power. If we burn the fuel in nearly pure oxygen, the result will be mostly steam plus carbon dioxide, CO2. These are easy to separate. This method is called an oxygen plus fuel cycle. On the other hand, we could separate the fuel before it's burned into carbon monoxide plus hydrogen plus other elements such as sulfur. Reacting these in a catalytic converter can siphon off the hydrogen to burn, harvest the other elements for fertilizers and plastics, and then we add some oxygen to make easy-to-handle carbon dioxide. Engineers call this method the pre-combustion cycle. Now, the trouble with either of these approaches is that they are way too costly to apply to an existing power plant. For that, we need to absorb the carbon as it goes up the stack, literally scrubbing the smoke. This third approach is called the post-combustion cycle. Once we have our compressed CO2, we need to move it, usually by pipeline, sometimes by ship. It's a stable substance. In fact, it's a natural fire extinguisher, because carbon dioxide displaces air, so it can be risky to life if it leaks into a confined, inhabited space. Naturally occurring CO2 from volcanoes has killed thousands of people. So our aim must be to capture the carbon dioxide somewhere for a very long time. This is called sequestration. To do this, our CO2 pipeline can safely end in one of 2 places: the deep ocean or deep within the crust of the Earth. It's theoretically possible to pump carbon dioxide directly into the sea if our hose doesn't open up until it's at least 3,500 meters deep. At that depth, the pressure is so great that CO2 should sink directly to the ocean floor, just like the fate of carbon at the end of nature's biological food chain. Now, this method is untested, and it could be very expensive. But what if we could put that pressurized CO2 to work? Happily, we can. Suppose we found a layer of porous rock between 2 layers that were sealed. Placing the open end of our pipeline there, the carbon dioxide would essentially liquefy under the pressure found at that depth. Our CO2 would flow to fill the spaces between the rock granules of the porous rock, but it can't get through the tightly packed crystals of the so-called cap rock. So our carbon will be effectively sequestered between the 2 layers. As the CO2 flows into the rock's pores, it displaces other fluids, hurting them elsewhere. If we do this in an area where we know oil to exist, even though it may be widely spread out, the injected CO2 can force enough of that oil together to make it economical to recover. This idea isn't new. Companies who drill for oil and gas have been using this technique for decades. So far, none of the sequestered CO2 has been known to leak. If we do this right, we could, in theory, turn our global carbon liability into a benefit. But let's face it, it is a big job. To bring humanity's carbon output down to the average level of the past 10,000 years, we would have to convert more than 4,000 coal plants. Now, if we hypothetically could shut down all the coal-fired power plants, we'd have to increase, let's say, the number of wind farms around the world more than 70 times over to get to the same level of energy production. Or instead, we would have to bring online 2,000 new nuclear plants, each with an output of at least 1 gigawatt. Or, just possibly, construct 250 gigantic solar power satellites in space. It's a far-out idea, but it just may work. So, compared to the alternatives, removing carbon from the energy equation and putting it to work safely, in other words, carbon capture and sequestration, may just turn out to be the best power production strategy money can buy.